model is essentially a long-term production model with capital accumulation. Now, the capital stock is no longer exogenous, but it is allowed to change, and we later see how investment causes it to grow and depreciation causes it to shrink. Now, the Solow model takes a production function approach to explain how real GDP per capita increases over time. Now, we'll build this model in a series of steps. In the first step, we'll start with the basic Solow model, where we don't have any labor population growth and we don't have any technological progress. We then will relax these assumptions by first introducing labor population growth. So we'll look at the Solow model with labor population growth and no technological progress. And then finally, we'll look at the Solow model with labor population growth and technological progress. So we look at three versions of the model. The first being the basic Solow model, where we don't have any population growth and we don't have any technological progress. The second version that we'll look at is where we'll have population growth, but we won't have any technological progress. The last version will be where we have both population growth and technological progress. So we'll start off looking at how do we set up this basic Solow model without technological progress and population growth. In this, we'll first discuss the production function. So we assume that two inputs, capital and labor. So our production function is given to us as y is equal to fkn, where y is our aggregate output, k is capital, n is labor. The production function shows us the maximum output the economy can produce from k units of capital and n units of labor. There should have been n, not l, because we're using n to denote labor here. Now, there's certain assumptions that we're going to make with respect to this production function in our Solow model. So we assume it satisfies constant returns to scale. So this means that if we scale all inputs by some amount, output gets scaled by that same amount. Mathematically, this means that if I scale both my inputs, capital and labor, by C, right, output also gets scaled by C for any C greater than C, right? So if we scale all inputs, in this case, both capital and labor by some amount, which in this case is C, output gets scaled by that same amount C. So multiplying both arguments, I, K, and N, with any positive constant C causes output to change by the same factor. Now, a fancy term for constant returns to scale is to say that the function is homogeneous of degree 1 in K and N. Right, so this is a more fancier term for saying that the production function satisfies constant returns to scale. A fancier way of saying this is that the production function is homogeneous of degree 1 in capital and labor. Now, where generally a function is homogeneous of degree p if I change inputs by c, output gets scaled by c power p, right? So if it's homogeneous of degree 1, then p is just 1, which means that the same factor by which you scale inputs, output gets scaled by that same factor, right? So basically, fancier term for saying that the production function satisfies constant returns to scale is just to simply say the production function is homogeneous of degree 1 in K. Because this is in general a function of homogeneous of degree P. So if P is equal to 1, it just corresponds to the same case we discussed. So now the second assumption that we'll make that a production function satisfies is positive and decreasing or diminishing marginal returns to both labor and capital. Here we need to look at a couple of definitions. Now here, MTN is the marginal product of labor or the marginal returns of labor. So this is the additional output that is produced when 1 unit of labor is added, holding all of the inputs constant. This is key that you're holding all of the inputs constant, right? Because when you're looking at returns to scale, you're changing all your factors of production. Like when we discussed returns to scale concept, we said we're changing all our inputs, right? Here we change both capital and labor wise. But when we talk about returns to factor, or when we talk about returns to factor here, we're just changing that particular factor and holding all of the inputs constant. So marginal partial labor is just the partial derivative of y with respect to n. We know y is just fkn, so we can also write it as a partial derivative of f with respect to n, which in subscript notation can be written as fn. Here the subscript n indicates that we're talking about the partial derivative of f with respect to n. MPK would be the additional output that is produced when 1 unit of capital is added, holding all of the inputs constant. And so marginal partial capital will just be the partial derivative of y with respect to k, since y is just fkn. So we can write it as the partial derivative of f with respect to k, and with subscript notation, we can write it as fk. And diminishing marginal products means as one input increases, again, the keyword is holding other inputs constant, its marginal product falls. This is what you mean when you say, so we know what would mean by positive marginal return of labor and capital. This would just mean MPN and MK are positive. What would we mean by diminishing marginal return? Diminishing marginal return simply means that as one input increases, holding other inputs constant, its marginal product falls. So it's very important to distinguish between returns to factor and returns to scale. So if we just go to that, so it's very important to separate concept of returns to scale. The first assumption we make about the production function is related to returns to scale, where we assume it satisfies constant returns to scale, where if we change all inputs by some factor, output gets changed by the same factor. The second assumption we make is concerned with returns to factor. where in returns to factor, we're just changing that one factor of production, holding other inputs constant. But in returns to scale, we're changing all factors of production, so we're scaling up or down the entire production process, right? So it's important to keep in mind the first assumption is concerned with returns to scale, where you're changing all your inputs. The second assumption is concerned with returns to factor, where you're changing that particular factor, holding other factors constant. So the second assumption involves positive and decreasing or diminishing returns to capital. So this basically means, by the term positive, we mean that when we increase capital, output increases. So the first derivative of y or f, you can, because y is fkn, of y with respect to k is positive, right? So this part is the positive returns to capital, right? When you're increasing capital, output is increasing. So the partial derivative of y with respect to k is positive. But the increase in output becomes smaller and smaller as level of k increases. So as k increases with fixed n, the marginal product of k decreases. Right? So when you increase k, y is always going to increase, but the increase in y is going to become smaller and smaller with increases in k. So as k increases with fixed n, marginal product of capital decreases. Because marginal product of capital tells us the additional output that is produced when you have one more unit of capital holding labor constant. So the additional output that you're able to produce becomes smaller and smaller. So the partial derivative, when I differentiate MPK with respect to k, which is just simply partial square y by partial k square, which is the second partial derivative of y with respect to k, that is going to be less than 0, right? So the positive returns to capital means the marginal part of capital is positive. The part of decreasing returns to capital means as k increases with fixed n, the marginal part of capital goes down. So the derivative of marginal part of capital with respect to k decreases. Similarly, we're assuming positive and decreasing, decreasing or diminishing margin returns to labor. So then this just simply means that, so let's just look at this just a second. Yeah, sorry. Okay, so sorry about this. So yeah, so what we're saying is the positive returns to labor simply means that if we increase n with fixed k, it will always increase out. It will increase out, right? So the marginal product of labor, which is a partial derivative of y with respect to n is greater than 0. Right, so this is supposed to be the partial derivative y with respect to n is greater than 0. But the decreasing or diminishing returns to labor part means that as n increases, the marginal product of labor decreases with fixed n. So the derivative of marginal product of n with respect to n, which is the second partial derivative of y with respect to n is less than 0, right? So here the positive part means that MPN is greater than 0. The diminishing or decreasing part means that the derivative of MPN with respect to n is less than 0. Because as n increases, y is increasing, but the increase in y is becoming smaller and smaller. So as n increases with fixed k, the marginal product of labor goes down. So this is the second assumption. Like we said, so the two assumptions I'm making the spectral production function. The first is concerned with returns to scale, where we're changing all the factors of production. So we're scaling up or down the entire production process. Here we assume the production function satisfies constant returns to scale. The second assumption that we make is concerned with returns to factor, right? In returns to factor, you're changing that particular factor of production, holding all its inputs constant. So it's important to distinguish between returns to scale, which our first assumption is concerned with, and returns to factor, which our second assumption is concerned with. And here we assume positive and decreasing returns to factor for capital and positive and decreasing returns to factor for labor. The positive part simply means the marginal part of labor and marginal part of capital is positive. The decreasing or diminishing part simply means the derivative of MPN with respect to n is less than 0 and the derivative of MPK with respect to k is less than 0. Okay, whenever you're increasing capital, output is increasing, but the increase in output is becoming smaller and smaller. Similarly, whenever you're increasing labor, holding capital fixed, output is increasing, but the increase is becoming smaller. If we're given a specific functional form for a production function, y is equal to fkn, we can check and verify whether both of these properties hold, right? So we can then check whether this particular production function satisfies constant returns to scale and whether it satisfies positive and decreasing returns to capital and positive and decreasing returns to labor. We'll typically work with a Cobb-Douglas production function, which takes the form y is equal to k alpha n beta. So this is a particular functional form for production function y is equal to fkn. And like we said, make sure to distinguish between the concept of returns to scale, which the first assumption is concerned with, and returns to fact, which the second assumption is concerned with.